Good day everyone, my name is Arslan and in today's video we're going to design a load-bearing wall foundation using Revit. These types of foundations are made for load-bearing structures which are usually residential houses or any other small structure, and they are, I believe, the simplest and the traditional way of making foundations for structures. So let's get started on Revit. And for our design plans, these are the two reference images which we are going to use. So this is the first image and this is the second one. Let me zoom in a little bit. Here you go. As you can see, the plinth level we have is usually 2 to 3 feet from the ground, from the road level or from the street level. So this is the reference image we have, and that's the idea we're going to apply. And in this case, there's a better representation of the image. So the first is the 9 inches brick ballast that we have, followed by the 4 inches of PCC, which is plain cement concrete, and then we have the 22.5 inches of bricks laid, and then that's 18. It gets decreased to 13.5, and then to 9 inches where we reach the street level. And from here, so this is the street level, and then it's 2 feet above and we'll reach the DPC layer, the damp proof cement layer. So this is the drawings and the reference that we're going to take when designing it in Revit. So let's get started. Let's go to Revit, and then let's go on to new uh, metric architectural template. Okay, so the first thing is always the units. We're in metric architectural. Let's press UN, and for the time being, let's set this to feet and the unit symbol to FT. Okay, so the next thing is the elevations, which is in fact the most important step, because elevations is what's gonna, it's gonna clear everything, all the doubts we have. We're gonna solve them by our elevations. And let me even say that the images that we're going to use, I do not own both of them. They belong to their respectful owners. So, but I'm using them as a guide, as a reference guide. So let's get back. So our main reference level is our road level or our street level. So we'll rename this to street. Would you like to rename the corresponding views? Yes. And this is going to be our DPC, or let's name it as a plinth level. And then the DPC would be 1.5 inch above this. So let's select this and copy multiple and constraint. Let's click both of them. So now let's select this level, and the difference between the road and the plinth has to be 3 feet. All right, it's usually between 2 to 3 feet, but I'm taking this as 3 feet. So let's change this to 3 feet, and this would be, this is the DPC level, so it would be 3 feet and 1.5 inches. Okay, let's decrease the scale by a little bit. Right. Okay, so that's our DPC level, and this is our plinth level, and this is our main road reference level, and the difference between both of them is 3 feet. So the more we make our elevations, the clearer the picture is going to get. So let's get back to our reference image. As you can see, there are a total of 1, 2, 3, 4, 5, and then followed by 9 inches of brick ballast, 6. So we need 6 levels. Okay, so let's get to Revit, and we need a total of 6 levels. Let's go to copy, constraint, multiple, and we'll write 6 inches. So now one level is made, another one of 6 inches, 6 inches again. Okay, so here we go. Now we have a total of 6 different layers below that. Let's try to change the scale a little bit. This is the road level and 0.5 feet. All right, let's go back to our units and let's set it to the nearest. Let's go to feet and frictional inches and to the nearest 1 inch. All right. Okay, now much better. Road and street level, that's at 0. And then we have 6 inches, the first layer, the second layer. So if you go back to our reference images, this one is going to be the 9 inches wall, and the other one is 13.5. So let's rename this 9 inches wall, 13.5 inches wall. After that we have the 18 inches and 22.5. So 18 inches wall and 22.5. Then we have 6 inches of PCC, plain cement concrete. PCC works are and then we have the last one is 9 inches of brick ballast. Let's add compacted brick ballast. Okay, the elevations are complete. Now let's get started with the massing and site. Let's go to site floor plan. Let's create our topo surface. Elevation 0, place points 1, 2, 3, 5. Let's move this point so that we wouldn't have any problems later on. Let's go back to our 3D. So this is our topo surface. Now we need the building pad. So the building pad is basically your main plot area, as I would like to call it. In fact, it is the plot area. So the plot we have is 35 by 80 feet. That's the plot area that we have. Let's go to wireframe for easier reference. Let's go to aligned dimension. We need to change the scale by a little bit. So 35 feet. And 80 feet. All right, so this is our main plot area, our building pad. Now, as you can see, the level, we have to set it to the 9 inches of brick ballast. All right, here you go. So this is our main plot area, our main trench, our main excavation that we would have to make. And with this now you can have an exact idea of what we're doing and what's going on. Because this is our main plot area, and now we're going to start the foundation. This is our excavation area right here. So For example, let's check the thickness of this. It's 1 feet. So let's set the height offset to -1 feet. And I forgot to mention that there's even a 1 inch of plastic polythene sheet, which is below the brick ballast. So we would even have to add that in Revit, and it's easier to add it. So now, once the building pad is done, let's start making our layers, the layers that we have. And we're going to use walls as our main layers, all right? So instead of using as components or any other thing, we're going to straightforwardly use walls. So the first layer is the 1 inch plastic polythene sheet. So let's go to architectural, and let's go to basic wall. Let's edit, we'll go to duplicate, and plastic polythene sheet of thickness 2 of width, sorry, 2 feet and 6 inches. Let's go to edit. Let's set the width to 2 feet and 6 inches. Let's go to materials, and we're looking for plastic. And okay, let's go for plastic transparent polyethylene. Right. So for this case, let's go for acrylic clay. I think this would be a better option. Okay, so oops. Okay, so this is the initial plastic sheet that we have, which has a width of 2 feet and 6 inches. So let's start making our floor plan. First the thing we have to do is you have to go to views, and we would have to create those floor plans that would usually show in the project browser, but they're not showing. So let's select all of them, and let's press OK. And as you can see now on the right side, we have all the floor plans that are created. Now if you go back to our elevations, so they're not black anymore, they're blue. If you remember, this is what I said in the start of the video. So the level that we would have to work on is the level that we would have to work on is the 9 inches of compacted brick ballast. So let's go to 9 inches of compacted brick ballast. Let's set this to shaded. Let's go to architectural walls, and let's choose the plastic polythene sheet that we made, and its initial the base constraint is the 9 inches of compacted brick ballast, and its height should be, let's go back to our southern elevation, its height should be the PCC layer. All right, in fact its height should be the 9 inches of compacted brick ballast itself, because the plastic polythene sheet is below this. So let's go back to our compacted. All right, and let's go to walls. So plastic polythene sheet, so the base constraint is this, and the base offset is -1 inches, because this is what usually is -1 inches, and the top constraint is again 9 inches of brick ballast. Okay, in fact let's change the top constraint to unconnected, and let's set the base offset to -1.5 inches, and let's set the thickness of this to 1.5 inches. So let's start making our floor plan. Firstly, let's go back to units, and let's set rounding to the nearest 1 1/4 inch. Right, this is fine. So let's start making our floor plan. Okay, none of the created elements are visible in floor plan 9. That's okay, we can fix that. let's first let's first fix this. Let's press the visibility graphics. So visibility range, let's set this to unlimited, and now I can see what's going on. So back to where we were. This is our floor plan. This is just so that we can have some sort of a structure to work with. Okay, so now let's click on this and select on instances visible in view. So now the base constraint is this layer. The base offset is minus 1.5 inch, and the top constraint is unconnected, and its height vertically upwards is 1.5 inch. So this is it. Let's change the building pad material, uh, and the thickness of the building pad is 1 feet. Let's first change this material. Let's go for earth, and let's change even the material of this. Let's go for grass. Okay, so now things are going to make sense as we move on. And the thickness of our polythene sheet is 1.5 inch, and the thickness of the building pad, as you can see here, it's 1 feet. So its offset is minus 1 feet plus the thickness of the polythene sheet, which is 1.5 inch. As you can see now, we're exactly right on our track. And now let's go to our, so the second layer after the 9 inches of compacted ballast. So we're done with the first layer, which is the plastic polythene sheet. Now we have to place the brick ballast of 9 inches vertically upwards. Alright, so let's go to our floor plans, and we need a wall. Let's go to generic 90 mm, but we would have to duplicate that. So brick ballast of 2 feet 6 inches width. Okay, and edit brick common, and thickness is 2 feet and 6 inches. Let's press OK, and its base constraint has to be the 9 inches of compacted ballast, and its top constraint has to be PCC layer. Alright, PCC layer is going to be its top constraint. So let's go back to our walls, and brick ballast. So the base constraint is that. The base offset, let's set it to 0. The top constraint is the PCC layer, and it's unconnected up to 9 inches. That is perfectly fine. So now the location has to be wall center line. Okay, now let's choose this, right click, select visible in view, and I forgot to change the width of this, so it's 2 feet and 6 inches. Okay, so let's go back to our 3D view, and this is it. Okay, we forgot the middle one. Let's go to VR, which is our visibility range, and let's go to realistic to have a better idea. Let's create similar. As you can see, the first layer is done. The 9 inches of PCC layer is done, and now it's the PCC layer itself. So again, the vertical elevation, it's 6 inches and the width is the same. So let's go back to our 9 inches. Let's go back to our southern elevation first. Now we need a wall from PCC layer to the 22.5 inches wall. And let's go to our PCC layer. Let's go to VR Unlimited. Okay, now everything is showing. Let's go to realistic. That thing is still missing. Create similar. Alright, this was the final part missing. Now let's go back to our PCC layer. Now we need another wall. So let's go to edit. Let's go to duplicate. And now let's change this to PCC. So rest everything is in fact the same, brick common, and the thickness is that. Okay, so let's start making our wall. The base constraint is going to be the PCC layer, and the top constraint is going to be the 22.5 inches wall. So PCC layer, wall, and the top constraint is the 22.5 inches wall. And as you can see, the unconnected, the top elevation is 6 inches, so it's correct. So let's just go to wall centerline and let's start making our wall. Okay, so now the second layer is even done. So now we have the plastic polythene sheet, followed by the 9 inches of brick ballast compacted, followed by the 6 inches of PCC layer. Now let's move on. Let's go back to our diagram. Now we're done with the brick ballast, the PCC layer, and then we have the 22.5 inches of wall. So we would have to make that, and its width is 22.5. So walls, edit, duplicate, and we have brick wall 22.5 inches. Let's go to edit. Okay, brick engineering gray. So now that's made. So our next layer is between the 22.5 inches to the 18 inches. So let's go to the 22. And you know, a good habit when it comes to elevations, it's the numbering. Because if you could see on the right side, they're arranged according to their first letter. So numbering it is always a good idea. Let's quickly number this 01. Now as you can see on the right, it automatically got arranged according to the number that we have given it. So we're done until the PCC. Now we need the 22 inches. The next one is the 22 inches, 22.5 inches to 04. So 03 to 04 is the next layer that you have to make. Let's go back to our 3D and let's choose walls. 22.5 inches. So 03 to 04. Let's go to 03. Wall. Again, as usual, view range. Let's set that to unlimited. And the base constraint would be 03. The top constraint would be up to level 4, which has a difference of 6 inches. And a line and wall center line. Alright. This we had left that out. So now the 0, 3 to level 4 is done. Now we have to start from level 4 till level 5. So an 18 inches wall is what we need. Let's go back to our walls, edit, duplicate, brick wall of 18 inches. Let's go to thickness, 18 inches, which is 1 feet and 6 inch. So let's go to our floor plans. Again, VR, which is our visibility range unlimited, and unlimited again, and walls, 18 inches wall. So its base constraint is our level 4 and its top constraint is our level 5, and the difference between both of them is 6 inches, and the location line is wall center line. Alright, we'd have to get back into 3D, and now our 18 inches wall is also done. So now the next step is from level 4 to level 5. That's the 18 inches, which is already done, as you can see, level 4 to level 5. Now from level 5 to level 6, which is a 13.5 inches wall. So let's go back to architectural. Let's duplicate this. We need a 13.5 inches wall. Let's go to edit. Thickness is 13.5 inches, and its material, let's again change it so that we could differentiate. We could easily differentiate between the. Alright, let's go to brick, common and brown. Choose this, and let's go to our floor plan, 13.5. So now we need it from level 5 to level 6. Let's go to visibility range, and let's start making our wall 13.5 inches. So its base constraint is level 5, its top constraint is level 6, and the difference between both of them is of 6 inches. Alright, so now even our this layer is completed. As you can see, this is our load bearing foundation and a load bearing wall foundation. Now our 13.5 inches wall is done up to level 6. So now we need a 9 inches wall to our road level or our street level. And let's go back to our architectural wall. Let's edit. Let's duplicate brick wall of 9 inches. Let's change the thickness here to 9 inches, and let's change the material here to brick, to another type of brick. Okay, let's go to for exposed masonry. Let's press OK, and now let's get to our back to our floor plans at level 6. VR, which is the visibility range, we would have to change that for every layer, for every floor plan. And architectural walls, brick wall of 9 inches, its base constraint is level 6 up to level 7, which is our road level. Now as usual, we'll go to realistic. Okay, so now you can see the 9 inches wall is completed. I skipped the video so that we could save some time, and now here's a better. Now you guys could have an idea of what the initial drawings were. We have the plastic sheet, we have the brick ballast, we have the PCC, then that's followed by the 22, 18 inches, 22 inches, 18 inches, 13.5 inches, and then we have the 9 inches, which is the topmost one, and every one of them has a 6 inches thickness. So at the 9 inches, as you can see, we have reached our main road level. So now let's go to our road level, and let's press VR. Okay, and we would have to again continue with that 9 inches wall. So we don't need to make any new walls in this case. Alright, so this is our main load bearing foundation. Now our 9 inches wall has, its top constraint is our plinth level. So after that we only have a DPC of about 1.5 inch, as you can see back in our elevations. Now our 9 inches wall is from this area, from level number 6 till the plinth level. Alright, till the plinth level. So for example, if we go back to our 3D, if we just select this and we go to select on instances in the entire project, so its top constraint is level 8, at number 8, which is the plinth level. So now the only thing left is our DPC, our damp proof cement layer, which is usually 1.5 inches. Okay, so in this case I was thinking about using model in place, but let's just use wall so that we could save time, and because the video is already it's past what I had planned. So duplicate and DPC 1.5 inches thick, and let's go to edit. Let's go to, for the material we'll choose something white. Okay, let's go for brick, sand and lime, and its thickness is 9 inches. So we'll go back to our DPC. Let's go for VR, which is our view range, unlimited in both the cases. And so let's go for walls. So its base constraint is going to be level 9, which is DPC, and its top constraint is going to be unconnected with a vertical elevation of 1.5 inches. Realistic. So our DPC layer is also completed, and let's go back to our 3D view, and here's our complete project. So this is a load bearing wall foundation for load bearing structures, which are usually residential houses. We have the initial plastic, the polythene sheet, and in fact let's change the material for this so that it's a bit visible. Let's write plastic here, and in the materials let's go for, we need something that's actually visible. Laminate. Okay, let's choose this. Alright, much better. So we have the 1.5 inches of plastic polythene sheet, we have the 9 inches of brick ballast, we have the PCC of 6 inches, then we have the 22.5 for 6 inches, the 18.5 brick wall for 6 inches, the 13.5, and followed by the street level, and that rises up to our plinth level. So this is our plinth height, which was 3 feet as we initially chose in our elevations. So from the road, from level 7 to level 8, this is our plinth height, which is 3 feet. And then we have, let's go back to, then we have the 1.5 inches of DPC. I've even added the DPC into it. So this is our entire load bearing foundation in Revit, and I hope you guys enjoyed the video, and stay tuned for more interesting videos. Thank you.